Today, we're going to solve problems in the same section, 5.2, computing indefinite integrals, but we are going to answer problems starting number 15 onwards. But I'll just select numbers since I can solve them in 1 hour. My time limit for solving problems or for recording or live streaming here in Bigo is 1 hour only. So it could be 1 hour to 15 minutes or 1 hour to 30 minutes because there are things, other things that I need to do. But hopefully, I normally go live from 7:30 to 8 p.m. Sometimes it's 7 something, 7:15, 7:20. Sometimes it's 8. It depends on my schedule of within the day. Hi, thank you for sending um that emoji. I don't yeah. I don't know if I can hear your voice. No, only your chat. Okay, so let's start. Let's try to solve problem number 16. So again, this is indefinite integration. So when we say indefinite integration, the limit of our integral is from negative infinity to positive infinity. If there are certain numbers on the integral sign, say for example 2 to 5, then this is called definite integral. So again, we'll answer number 16. I am using my mouse right now since I was not able to get a pen, a writing pad. So we'll just use the mouse. The given problem is the integral of 12 of 12. The integral of 12 plus cosecant of theta times the quantity of sine theta plus cosecant of theta. Sorry about the writing. D theta. So again, um, if we have this integration, we have this given, all the terms in between the integral sign and the derivative should be integrated. So these terms. But let's check first our formula if we can directly integrate them. So as you can see, there is a multiplication here, cosecant times the quantity of sine theta plus cosecant theta. And if we check the given integral formulas, we only have here cosecant and cotangent, which is equal to negative cosecant plus c. And this is not cotangent, but this is sine, this is cosecant. And so which means there are things that we need to do. So we might need to combine first these so that we can find the integral. Now let's start to solve. So I can rewrite this. I can distribute cosecant to the um, brace here or bracket to the bracket or distribute that. So that would become 12 plus, sorry about that. Okay. uh, It's difficult to control the mouse. 12 plus cosecant theta times sine theta plus cosecant times cosecant will be equal to cosecant squared theta. Then we should not forget the theta. Afterwards, we can write this as the integral of 12 d theta plus the integral of cosecant theta times sine theta d theta plus the integral of cosecant squared theta d theta. For 12 d theta, we can actually integrate this. For this term here, we don't have any formula given. So there might be some properties that we can use, but let's check later. Then we have here cosecant theta d theta. So we have an integral here. But let's focus first on this term. Now, if you are familiar with trigonometric functions, cosecant theta is actually equal to 1 over sine theta. So let's check. Let's search. Okay. Trigonometric. I think that's trigonometric properties. I forgot. Trigonometric properties or trigonometric identities. So let's check trigonometric identities here. So So my memory is still working. So sine theta is equal to 1 over cosecant theta. And the same way, cosecant theta is equal to 1 over sine theta, which means we can replace sine theta, either sine theta or cosecant theta. So it depends. If we will replace sine theta, so that means our sine theta is equal to 1 over cosecant theta. We get this by cross multiplying these two. So sine theta and cosecant theta will exchange places. And if you substitute that, so we'll rewrite this as 12 times the integral of d theta plus the integral of cosecant theta times 1 over cosecant theta d theta. Then plus the integral of cosecant squared d theta. Next, so we will not integrate yet because there is a term there here that we can simplify. So that's 12 times the integral of d theta. Cosecant theta times 1 over cosecant theta will be cancelled out. So what would be left is 1. So that would be 1 d theta plus the integral of cosecant squared d theta. In here, we can now integrate each of these terms. So that means the integral of 12 d theta is equal to 12 theta plus the integral of d theta is just theta. So if we check here, uh, here is d theta, so that's x. And if it has a constant coefficient, so that's a times x. So this is a times x. This is similar with a times x. And this is x. All right. Then, oh, Then we have here the integral of cosecant squared theta. So let me correct this. So this should be theta d theta. Also here, so that's cosecant squared theta d theta. So the integral of cosecant squared theta d theta is negative cotangent theta. So we use theta here because theta is given, it's variable. In the example formula, it's x. So it depends on what variable is given. And please do not forget to write plus c, plus any constant value. Now, we can combine like terms. We have your 12 theta and theta. So which means this will become 13 theta minus plus times negative is, or positive times negative is negative. So that become minus cotangent theta plus c. So this will be our final answer for problem number, what problem is this? It's problem number 16. So we can check if our answer is correct. Paul provided us an answer. So let's check. Okay. This is what he did. You have here 12. Oh, it's the answer. Okay. He just automatically used the trigonometric identity. He applied directly trigonometric identity, and that becomes 13 plus cosecant squared. But let's check the final answer. We should have the same final answer. Yeah, we do have the same final answer. So let me just zoom out, zoom in, zoom out. Okay. So that I can adjust the size. How about here? Okay. So let's scroll down, and this is the final answer. We have, we have 13 theta, so we're correct, minus cotangent theta plus c. Therefore, we got the correct answer. So Paul's solution is, I think, much shorter, since we did not combine directly as cosecant theta. We did not use directly a trigonometric identity here. So what we did is we separated them before we had combined them. But it's okay. We still have the same result. Still get the same result. Okay, so thank you. And we got the first problem for today correctly. So we'll proceed with the next problem. We are done with 16. What's this? What's number 17? It's not familiar. So, but we'll try. We have formula here. We have a formula here, so this would be very helpful for us. Okay, we have this one. E to the x dx is equal to e to the x plus c. So just e to the x plus c. It's quite tricky here. What if it's e to the 2x? Yeah, if I remember it correctly, it's the derivative of the exponent times e to the x. Or I don't know, I forgot. So let's search it. We will use Bing. No, the integral of e to the 2x. Let's try e to the 2x. So the integral of e to the 2x is ex squared. What is this? So we have factor out the constant. No, sorry about that. What should I do? I think it's somewhat a substitution method. Now let's just study this one. So e to the 2x. So that would be okay. Yeah, we use substitution. So we let u, since we don't have an integral of e to the 2x, so we will change these 2x into a single variable, which is u. But we need to determine first, okay, the derivative of 2x. So 2x is 1/2 du. I think that's it. So that's why we have 1/2 du here. Okay, so that's how we solve e with an exponent. But let's check if, so I'm just thinking in advance. But let's check the problem first. So we have here, oh no, 17. That's the integral of 4 e to the z plus 15 minus 1 over 6z dz. Then we'll separate them, integrate them separately. This will become 4 e to the z dz plus the integral of 15 dz minus the integral of 1 over 6z dz. After, we'll move out the constant value. So that's 4 times the integral of e to the z dz plus 15 times the integral of dz minus 1 over 6 times the integral of, so that would be z, 1 over z dz. Okay, so what will we do with this? Let's check our formula. We know the integral of e to the z dz, that is here, e to the x dx. We know the integral of dz, that's here, equivalent, same with integral of dx. But what is the integral of 1 over z? Okay, x to the n, sine, second. Oh, it's here. Luckily, it's here. So we don't need to think about it. And we'll just write their integrals directly. So that will be 4 times the integral of e to the z dz is just e to the z. So in our example, that this our formula, it's e to the x dx, e to the x. But since we are using the z as a variable, so we'll change x to z. Then we have plus 15 integral of dz is just z minus 1 over 6 1 over z, integral of 1 over z, you have your integral of 1 over x. So that is the ln of x. What's ln of x? That's logarithm. I think this is natural logarithm. Then we have plus c. So this should be our final answer. And we will compare it with the answer of Paul. This is number 17. So let's check. Let's hope that we got it correctly. So that is for easy. Okay, to the z, 15z, and 1 over 6. Ah, no. Okay, my bad. Sorry about that. I used x. So this should be ln of z, not x. ln of z. Okay, so let me write it correctly. ln of z. Okay, so that's our mistake. I used x instead of z. Hello, everyone. Now let's solve another problem. We're done with number 17. So which is next? We have here problems 18, 19. Let's try 18. Okay, hope we can easily answer it. So number 18. For number 18, this is the integral of t cubed minus, so look at that, e to the negative t minus 4 over e to the negative t times dt. So again, we will integrate all the terms in between the integral sign and the derivative of t. So we will integrate them separately. So this will become the integral of t cubed t to the power of 3 minus the integral of e to the negative t minus 4 over e to the negative t dt. So let's check first our formulas. If we can find something like this, we know we can solve directly the integral of t to the 3 or t cubed through this formula, But let's check e to the t minus 4 over all over e to the negative t. Oh, we only have this one, no other e's. Let's check. Yeah, no other e's. Hyperbolic, exponential, logarithmic. Yeah. So, well, so I think, or the best thing to do is to simplify first this equation or this term. So we'll have t cubed dt. Let's try to separate these two. So we have e to the negative t over e to the negative t. Oh, we can cancel it out. Minus 4 over e to the negative t dt. So we can cancel out e to the negative t, and what would be left is 1. And so since the exponent is negative, then we can make it positive. Again, in the rule of exponents, if say for example you have 1 over x to the power of 2, we can also rewrite this as 1 over or x to the negative 2. So if we have 1 over x to the negative 2, that would mean this is equivalent to x to the negative of negative 2 or x squared. So which means, okay, I think we can solve it now. We have t cubed dt minus the integral of dt. Okay, then no, just 1. We'll write that we'll distribute the integral sign later. So this is just 1 minus 4 e to the t dt. Okay, so we can integrate it. But let's just distribute first the integral sign because we want to integrate them separately. So this would be this one. So that's minus integral of 1 dt. Then this one here. So that would be negative and negative. That would be plus the integral of, so let's move out 4 since it's constant, for e to the t dt. Okay. So here, the integral of t to the 3 is t to the 3 plus 1 over 3 plus 1. minus the integral of dt is just t, then plus 4 integral of e to the t is just e to the t, e to the t. And we should not forget, after integrating all of the terms, we should not forget to write c. Simplifying further, this is equivalent to 1 over 4 t to the fourth. So that's 3 plus 1. 3 plus 1 is 4. Then minus t plus 4e to the t plus c. So let's check if our solution and Paul's solutions are the same. Okay, this is number 18. We have number 18. Number 18, check solution. So show step 2. Okay. All right. So the first term is 1 over 4 times t to the fourth, correct? Next is negative t, this correct also, plus 4e to the t and plus c. And we got it right. Okay, let's go back to the problem list. And that is number. So which will we choose? Which will we solve? I don't know yet. I don't know yet. Let's try number 20. By the way, for number 9, 19 rather. Okay, I'll just show a short. I'll just quickly answer number 19 because I believe we had already solved problems in this form. So we have 6 over w cubed minus 2 over w dw. And this is equivalent to 6 times the integral of 1 over w cubed minus 2 times the integral of 1 over, I forgot, sorry. Do not forget to write derivative of w minus 2 times integral of 1 over w dw. We can rewrite the first term into w to the negative 3 dw, then as is for the second term. So this will become 6. The integral of w to the power of negative 3 is w to the power of negative 3 plus 1 over negative 3 plus 1 minus 2. The integral of 1 over of this one is equivalent to ln of w. So we should not forget that if the given is 1 over a variable which has a power of 1, so it's actually ln or natural logarithm, this one. So which means this is 2 times ln of w, and we should not forget to write c. For indefinite integrations, do not forget plus c. And this is 6 times w, what is negative 3 plus 1, that is negative 2. So which means this is also negative 2 minus 2 ln of w plus c. We have here 6. 6 divided by negative 2, that should be equal to negative 3. So this is negative 3 w raised to power of negative 2 minus 2 ln of w plus c. So let's have a quick look at the answer of Paul to this problem. Okay, number 19. So SB 19. All right. So we have here negative 3w square, negative 3w to the power of negative 2 minus 2lnw plus c. And we got it right again. Thanks. Great. That's great. So let's solve the next problem. This is number 20. Number 20. Number 20 is the integral of 1 over 1 plus x squared plus 12 over the square root of 1 minus x squared times d of x. Do we have integral formulas for these? Let's check. Uh, hope we have. Hope we do. Yes. Let's try to zoom it out. Zoom it in, zoom out, zoom in. Okay, here it is. Where? Oh no, it can't be zoomed in. Can we open image in the new tab? Okay. It says yes. Yes, we can open image. Here it is. Here they are. Here we are. Yeah, we have here square root of 1 minus x squared. Yes, we have 1 over x squared. So this can be easily integrated. Let's show the solution. This is integral of 1 over 1 plus x squared dx plus, again, we move out 12 since that is a constant value, and that's times the integral of 1 over square root of 1 minus x squared dx. Then here we have the integral of 1 over 1 plus x squared dx is tangent to the negative 1, or we read that as arctangent. So that is arctangent of x. And we have plus 12, 1 over square root of 1 of x squared. So the integral of that one is negative, or arc sine of x. Again, if you're done with integration, we should not forget c. So let's check all. What's your answer? Number 20. Oh, oh, oh. I don't know what happened. There really isn't too much to do other than to evaluate the integral. So that's arctangent of x plus 12 sine to negative 1 of x. Note that because of the similarity of the derivative of inverse sine and inverse cosine, oh, we our teacher taught that it's arctangent, but it has also another name, inverse. Inverse sine and inverse cosine. An alternate answer is this one. So that means there are two possible answers for the problem. The first one is the first solution or first answer is the one that we have solved. The second is minus 12 arc cosine or inverse cosine. Let's check. Oh, where can we find that the integral of 1 over square root of 1 minus x squared dx is arc cosine, negative arc cosine? I don't know. There is none. Arc sine, arc cosine. We couldn't find it. Maybe there is an explanation for that. There is a separate solution, probably on the properties of inverse trigonometric identities? Let's check. We have B-juice or bi-juice. Let's check if you have that arc, inverse, inverse. Let us see inverse or arc. Half angle identities, product sum, trigonometric identities, proofs. None, 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 none. Okay, none. But anyway, since Paul is an expert of that, and I think there is really a solution to that. I just don't know how. But for now, so since we got one of the correct answers, so which means our answer is correct. So our solution is correct. So let's proceed to the next problem. Let's back to the problem list. Let's go back to the problem list. Okay. Hmm. Let's try problem number 22. What's with this? There is now a condition. Determine f of x given that f prime or the derivative of x is equal to 12x squared minus 4x and f of negative 3 is equal to 17. So which means if x is equal to 3, negative 3, the answer should be 17. How should we solve this one? But let's try. I don't know. I really don't. I'm not sure. But let's try. So problem number 22. That is find fx if f prime of x is equal to 12x squared minus 4x and f of negative 3, that means when x is equal to negative 3, it's equal to 17. First is let's find f of x using f prime of x. So we can rewrite this one as the derivative of x. F prime is the derivative of x. So we can rewrite this as an fx is equal to the integral of f prime of x. So that would be the integral of 12x squared minus 4x dx. Afterwards, we'll integrate them separately. So that is 12 integral of x squared dx minus 4 integral of x dx. Okay, then let's integrate. This will now become x squared plus 1 over 2 plus 1 minus 4 times x to the 1 plus 1, since there is actually a power of 1 here. But the convention says it's okay to not place 1 because any value which don't have an exponent shown has a power of 1. So that's 1 plus 1, and let's not forget c. And next is we have 12 times 2 plus 1 is 3, so that's x cubed over 3 minus 4 times 1 plus 1 is 2, so we'll get x squared over 2 plus c. So I think I know now what's the use of the given condition that f of negative 3 is equal to 17. I think that can be used in finding c, but let's check later. So we have 12 divided by 3. This becomes 4. Since 12 is divisible by 3, that's 4 times 3. And we have 2, then this will become 2. Our answer will be 4x cubed minus 2x squared plus c. So this is now our f of x. And we have here a condition. So let's put here a box. So that means this is our solution. So we have a condition that f of negative 3 is equal to 17. So if this is f of negative 3, that means our equation will become 4 times negative 3 cubed plus or minus 2 times negative 3 squared plus c. And we are told, or based on the condition, this is equal to 17. And we have 4 times negative 3 cubed is 3 squared is 9 times 3. That's negative 27. Am I right? 3 times, um, or 3 times 3 times 3. So that's 27. Then minus 2 times negative 3 squared. So this will become positive 9 plus c. Then we'll have 17. So what is 4 times negative 27? Is it negative 108? 108? So let's check. Um, 4 times negative 27. So yeah, that's negative 108. Minus 2 times 9 is 18 plus c. Then we can transpose these two here on the other side so that their signs will change. So it becomes 17 plus 108 plus 18 is equal to c. Then add all of them. So this is now 17 plus 108 is 125 plus 18, that's 144. Oh no, 43. So so let's check. If you are very good in arithmetic, then you can answer that one directly. So this is 143. So this 143, I love you. Or we can rewrite this as c is equal to 143. So let's just check. So I really, I'm really not sure if this is what we need to solve. This one and this one. But let's check. Hopefully we are correct. Okay, we have here, this is the answer, 4x cubed. So in the first step of Paul's notes, so we have 4x cubed, that's correct. Negative 2x squared, we're correct again. And plus c. Now let's check step 2. Because we have a condition, we can just plug x is equal to negative 3 into our answer from the previous step. Set the result equal to 17 and solve the resulting equation for c. So which means our final answer should be, so this is not yet the final answer, But the final answer should be f of x is equal to 4x cubed minus 2x squared plus 143. I actually um got the hinge, or I so my assumption is actually correct that we need to use the given condition to solve for C. But what I lack is the final answer. I forgot we just need to substitute the value of C here. So this is now our answer. F of x is 4x cubed minus 2x squared plus 143. I guess if my teacher would check my solution, there would be a deduction since I was not able to write the final answer. Okay, but so much of that. Let's go back to the next problems. Hmm. Let's. There's only two problems left. Oh, that's great. So we have number 23, 23, and that is, what is g of z if g prime of z is equal to 3z cubed plus 7 over 2 times square root of z. We still have minus e to the z, given that g of 1, that means when z is equal to 1, our g is equal to negative or 15 minus e. Oh no. Let's try. First is we need to integrate again to get g of z, we need to integrate g prime of z. And that's integral of 3z cubed plus 7 over 2 square root of z minus e to the z dz. So we cannot integrate this one if we don't have dz. And so let me just show you the step-by-step process so we can directly solve them. We can directly integrate them, but just let me show the steps. So this will become 3 times z cubed dz plus 7 over 2 times the integral of 1 over square root of z dz minus the integral of e to the z dz. I know how to integrate z cubed and e to the z, but let me check first how to integrate 1 over square root of z. So let's check if there are some properties that can be used directly to solve for these. Square root, let me check if there is square root. No, but it's just these. There should be a number, none. So which means we can use the only property or formula that we can use is this one. So let's just rewrite here, just right here. You have z cubed dz plus 7 over 2 times integral of z to, what's that? Square root means z to the power of 1/2. And since it's 1, okay, let me use the different color. Okay. So we have there square root of z is equal to z to the power of 1/2. However, it's written as 1 over square root of z, which means if this is 1 over z, this should be z to the negative 1. So if it's 1 over square root of z, then this is z to the negative 1 half. So therefore, we will write this as z to the negative 1 half dz minus e to the z dz. Then integrate, integrate, integrate. So that's z 3 plus 1 all over 3 plus 1 plus 7 over 2 times z to the negative 1 half plus 1 over negative 1 half plus 1 minus integral of e to the z is just e to the z. And we should not forget our c. Let's simplify. This is now 3 times z to the fourth over 4 plus 7 over 2 times negative 1 half plus 1 half, 1 rather is positive 1 half over 1 half minus e to the z plus c. So this is 3 fourths times z to the fourth plus 7 over 2 times, if it's in the denominator, and if we want to transfer it to the numerator, then we will reverse the fraction. So this will become 2 over 1 or just 2 times z to the 1 half minus e to the z plus c. Then we still have 3 fourths times z to the fourth plus, we can cancel this out. We have 7 z to the 1 half minus e to the z plus c. So this is now our, it's g of z. Okay, that's g of z. But we have here a condition that when z is equal to 1, we have 15 minus e. So if, again, based on the condition, if z is equal to 1, where should I write it? So when z is equal to 1, then g of 1 is equal to, what's that? That's 15. That's 15 minus e. So we're going to substitute 1. So let's have g of 1 is equal to 3 over 4, 1 to the fourth, plus 7 times 1 to the 1 half minus e to the 1 plus c. Again, this is g of 1 is 15 minus e, and that is equal to 1 raised to 4 is just 1. So that's what will be left is 3/4 plus 1 raised to 1 half. So whatever we do to 1, it will always be equal to 1. So we have 7 minus e to the 1 is just e. Then we have plus c. So we are looking for c, so we can trans we can rewrite this. So let me just rewrite this. This is equivalent when we write this as 3 over 4 plus 7 minus e plus c is equal to 15 minus e, so that I can transpose these three terms to the other side, and what would be left here is c. So that means our c is equal to 15 minus e. Then we have, this will become negative 3/4. Then we have here negative 7. Then plus e. Right? Okay, let's check. Then simplify. We can combine these numbers, then these two. So that would be negative e plus e, that's 0. But what is 15 minus 3/4 minus 7? So we can use least common denominator. So that's 4. 4 times 15 is 60. Then minus 3. 4 times 7 is 28. So we don't, this is now 0, so no need to add 0. And let's subtract. 60 minus 3 is 57 minus 28. So this is 9 and 29. So that is 29 over 4. That means our f of x is equal to, what's that? Oh, not f of x, f of z. So, no, not also f. Sorry about that. That's g. Because we solve, most problems that we solve are f of x. But we have here g of z is equal to 3 over 4 z to the fourth plus, what's that? 7z and 1/2. 7 z to the 1/2. Then minus e to the z. And we now have the value of c. Our c is equal to 29 over 4. I hope this is right. Okay, and I'm on my time limit. So let's check, let's check, let's check. Let's check the answer. The answer to 23. 23 is the problem. Okay. We have here, that's 3/4. So let's have 3/4, z to the 4th, that's 1. 7z to the 1/2, all right. And e to the z. So what is lacking is the c. No, 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 no. Yeah, we got it right. That's positive 29 over 4. And we are correct. That's it. I'll stop with this problem number 23. So I believe you can answer 24. Let's check. It's actually double integral. So since it's double derivation or double differentiation, so we need to integrate it twice. So it's a long process. It's a longer process because we need to integrate and integrate only twice. So that's because we are looking for h of t, but the given is h prime of t. That means this what would be happen. So the integral of h prime of t is actually if there should be dt. So I think there is no need since we use this prime, but the integral of that one is h prime of t plus c. And it's still not h of t, but h prime of t. So that means we need to integrate h prime of t plus c. And that would be equal to the integral of, oh no more integral. That would be equal to h of t. Then what would happen to the plus c? So that would be, so the integral of c is, so that would be plus ct, because the integral of c dt is ct. So that's ct. And another plus c. So this would be c sub 1 and c sub 2. That's why we also have two given values here, because that we have two variables or two unknowns, c sub 1 and c sub 2. Okay, so I hope we can answer that, but I'll try to answer this one tomorrow before I'll proceed to my next review in, I think that would be definite integrals. Okay, thank you very much for joining me today. I hope to see you again in our next video. Goodbye.